Welcome once again to my channel Blue Chip Finance, and in this video we are going to continue our previous lecture, which has a topic of economic order quantity, uh, which is a subtopic of inventory management। और इस वीडियो के अंदर हम मज़ीद आगे क्वेश्चंस जो हैं उनको डिस्कस करेंगे। तो जे हेज़र की जो बुक है ऑपरेशन एंड प्रोडक्शन मैनेजमेंट, उसी में से आगे हम चलेंगे। A large law firm uses an average of 40 boxes of copier paper a day. The firm operates 260 days a year. Storage and handling cost for the paper are $30 a year per box, and it costs approximately $60 to order and receive a shipment of paper. Number one, what order size would minimize the sum of annual ordering and carrying cost? And number two, compute the total annual cost using your order size from part A. And number three, except for rounding, our annual ordering and carrying cost always equals at the EOQ. So first thing is to note the demand. As we know that a large firm uses an average of 40 boxes of copier paper a day. In one day they use 40 boxes, and there are 260 days in a year. So yearly demand is 260 multiplied by 40 equals to 10,400, and according to this question, ordering cost is 60 and holding cost is 30. So first requirement is what order size would minimize the sum of annual ordering and carrying costs. So economic order quantity is 2ds divided by h. So 2 multiplied by 10,400 multiplied by s60 and divided by h30. So 204 units is your EOQ. The next requirement is compute the total annual cost using your order size from part A. So total cost is equals to annual holding cost plus annual ordering cost. If other cost is not given, then your annual holding cost is equals to your economic order quantity divided by 2 multiplied by h plus demand divided by economic order quantity multiplied by s. So Q is 204. 204 divided by 2 multiplied by h is 30, and D is 10,400 divided by Q, which is 204 multiplied by 60, and 30 60 plus 30 58.82 equals to 6118.82. So that is your total cost. And third one is that except for rounding, are annual ordering and carrying costs always equal at the EOQ? Yes, obviously these both are equal, as you are seeing here in this question that annual holding cost is 3060 at EOQ, and your annual ordering cost D by Q multiplied by S at EOQ. There is a slight change of just fractional points, that is 3060 and that is 3058.82. and in all previous question you noticed, you should have noticed that annual ordering cost and annual holding cost at EOQ level both are same. So we can say that except for rounding, our annual ordering and annual carrying cost always equal at the EOQ. So the next example is a local distributor for a national tire company accepts to sell approximately 9600 steel belted radial tires of a certain size and tread design next year. Annual carrying cost is 16 per tire and ordering cost is 75. The distributor operates 288 days a year. What is the EOQ? How many times per year does the store reorder? what is the length of an order cycle, and what is the total annual cost if the EOQ quantity is ordered. So first of all, your demand is total 9600 units and ordering cost is 75, and your holding cost is 16, and you operate 288 days in a year. So economic order quantity is 2ds by h. Just simply put the data and calculate it. The result is 300 units. And how many times per year does the store reorder? So reorder is simply optimal number of orders per year. D by Q is equals to your total demand is 9600 per year, and in each order you can acquire 300 units according to EOQ. So there are 32 orders per year. And in C, that what is the length of an order cycle? So length of an order cycle is just simply Q by D multiplied by number of days in a year. Your EOQ is 300 and your demand is annual demand is 9600 units, and you operate 288 days in a year. So length of an order cycle is 9 days. And the next one is that what is the total annual cost if the EOQ quantity is ordered? So at EOQ level, annual cost is equals to annual holding cost plus annual ordering cost. So annual holding cost Q by 2 multiplied by H plus annual ordering cost D by Q multiplied by S. So Q, economic order quantity, is 300 divided by 2 multiplied by H is 16, and demand is 9600, and Q is 300 multiplied by S, which is 75, and economic order quantity is 300. So total cost is 4800. So here you are observing that the question which is asked in the previous question, that at EOQ level does annual order holding cost and annual ordering cost are same except for some fraction, and here you are noticing that these both are same. 2400 plus 2400 equals to 4800. The next question from here, the topic is slightly changing optimal size, and it goes to the optimal size of production run. So here question is that Radowilski Manufacturing Company in Hayward, California makes flashing lights for toys. The company operates its production facility 300 days per year. So just get the data along the question. So days per year are equals to 300 days. It has orders for about 12,000 flashing lights per year, and your demand D is 12,000 per year, and has the capability of producing 100 per day. So in this question they are telling you about the capability of producing flash lights per day. This capability, production capability P, is equals to 100. So setting up the light production cost is $50. So ordering or setup cost is S equals to 50. The cost of each light is $1. So cost is also given in this question, which is $1, and the holding cost is 0.10 per light per year, and holding cost, which is 0.10, is also given. So here in this type of question you have to calculate daily demand, as you know that demand is denoted by D. So we just alter to differentiate between these two. I place here D1, because to differentiate between annual demand and daily demand. So D1 is simply equals to uppercase D, that is demand, divided by number of days in a year. So 12,000 divided by 300, and that is daily demand 40. So now first of all, what is the optimal size of the production run? So optimal size of production run, which is also denoted by Q, here formula is changed. Here it is equals to 2ds divided by h, which is already equals to EOQ. But here we multiply 1 minus d1 by p. The case in which daily production capability is given, you should use this formula instead of 2ds by h. So 1 minus d1 by p, so 2 multiplied by d is 12,000 and s is 50, divided by your holding cost is 0.10, and multiply by 1 minus d1 is already calculated here, that is equals to 40, and divided by production capability, which is 100. So finally your answer is 4472.13 units. So that is optimal size of production run. And now what is the average holding cost per year? Holding cost per year, same logic should be applied here. Here we placed 1 minus d1 by p with h. So when we calculate average holding cost per year, as in the previous case, you know that it was equals to q by 2 multiplied by h, but here it is equals to q by 2 multiplied by h multiplied by 1 minus d1 by p. So q is 4472.13 divided by 2 multiply by holding cost is 0.10 multiply by 1 minus 40 divided by 100, and it is equals to 134.1639. And average setup cost per year, same formula should be applied here, which we already used in the previous questions, that d by q multiplied by s. So d is your annual demand, that is 12,000, q is your optimal size of production, or simply you can say economic order quantity, multiply by s, and that is equals to, after putting the data, it is equals to 134.16. And at fourth number, what is the total cost per year, included the cost of the lights here. One thing should you remember that here cost of each light is also given. So if it is not given, then it is simply equals to this plus this one, but here cost of each light is also given, so we should use it along these two under our consideration. So here total cost is average holding cost per year, that is 134.1639, and plus average setup cost per year, that is 134.16, plus D is your demand, annual demand, that is 12,000, and each unit cost is $1, and your total cost is 12268.32. So in the next video we will also discuss some more questions related to this topic, and later we further move on to some new topics related to operation and production management, and I will also discuss with you remaining video lectures related to investment and portfolio management. In the class I already discussed a lot of portion of investment and portfolio management with you, but in the form of videos lecture I will also deliver those topics and discuss with you. So till then, Allah Hafiz, take care of yourself and other persons around you. Thank you.